we're going to actually be able to calculate instantaneous rate of change exactly. Okay, that's what the derivative is for. So we start off with the definition, and all of chapter 3 is calculating derivatives. All the different ways we can calculate derivatives. Kind of like limits, you'll have your list of how to calculate derivatives. All right? So it's going to be pretty heavily algebraic today and tomorrow. So we had let's just call this f, right? Some function. That's a secant line, correct? Yeah. So a secant line.
Leadership needs to report to the gymnasium along with student council.
Baloney.
Wow. Getting slim. A secant line.
No, I'm in the club.
What is the slope? The slope represented average rate of change, right? And that formula was this is B, this is A. Correct? This is all stuff we've learned. Average rate of change. How did we calculate instantaneous rate of change? So if I had some point and I wanted to calculate instantaneous rate of change, how do we do that? Do I remember? No? We picked 2 points, really close, right? Like 1.99 and 2.01. Yeah, so we have now estimated so that's how we'd estimate the slope. Okay. The red one's called a tangent line. The slope is the instantaneous rate of change. The question would be, how could we calculate the slope of that line, right? Turns out we get to use limits. We're going to define, see this little interval here between this point and that one? We're going to call that some value h. It's some small value like 0.01, correct? What would we want h to be to get this exact? How much space is in there? h is this big, but I want it to be this big. What is that h value? 0. So if I can close this gap to 0, then I will have that instantaneous rate of change, right? So we do a limit as h approaches 0. There's your limit definition of a derivative, number 1. We have 2 definitions to go over today. I'm just doing one. Okay. So if I want to calculate the instantaneous rate of change, the slope of a tangent line, this is one way to do it. Okay. So slope of a tangent line, instantaneous rate of change. In context, it might be called velocity, speed. We have a bunch of different words for it that you'll have in your brains. Okay. So calculate slope of a tangent line to f of x equals x squared, x equals 2. We'll just start easy. Every time you do one of these, I recommend you write the formula down. It's called memorization, right? So the limit, h approaches 0, f of x plus h minus f of x over h. Write it down every time. Okay, and I guarantee you'll have it memorized without even trying. We have an x value, correct? So it's a 2. So that's basically what we're going to do. We're going to calculate that. Right? What? Again, stay organized in your work on these because it can get messy. What's f of 2 plus h? Squared. Right? Plug in 2 plus h. F at 2 is 2 squared. You with me? So what's 2 plus h squared? H squared, no. Plus 4h plus 4. FOIL, remember. And I swapped positions. It's not a big deal. Plus 4 minus 4 is 0. Thank you for that. Anybody see what to do now? Yep, factor. cancel, right? Plug and chug. Very straightforward. So if you're looking at the graph at x equals 2, slope of that 10 minus 4. The instantaneous rate of change at x equals 2. Lots of ways to describe that. Okay. Can I write an equation for that line? I told you last year this would come into play a lot. Here it is. What point is this? Plug 2 in, you get 4, right? Yeah. So what's my equation? Don't. All you can do is screw it up. It's correct. Leave it. Remember, don't mess with it. All you can do is mess it up. If you have this as a free response, that's your answer. If you work this out to y equals and you mess it up, you lose your point. Okay? No touchy. Please go. No touchy. Okay? You'll get used to it. All right.
Please and thank you.
This is a 2-day assignment, so those of you that missed some stuff, you can watch the video or I can hit it tomorrow. 2.
Outdoor club. Please report to the gymnasium.
What's today? Thursday?
Yeah.
Friday, Tuesday.
Yeah.
Tuesday?
So 2 days, 2-day lessons, so I'm giving you 2 days.
We're gonna say
Whoa. Page 57, it's the pre-calculus review stuff.
You don't mind telling me that.
So 3.1, you get 27, 11, 15, 19.7, 45. Page 57, 12 and 26 for spiraling. AP2, 1 through 3.
Is this on classroom?
Yes.
What's that, AP2?
Let's do tomorrow
Okay.
then.
That
Yeah.
worksheet. Let's do Tuesday.
Okay.
Can you do me a favor? Can you go back one so I can figure it and what is it? What sheet?
This is due Tuesday as well.
Any questions? The bell's gonna ring pretty quick.
I was just being out there, I was like, I have feedback to give because of the
It's on classroom as well, so.
We don't have any
So tomorrow, we'll hit another one of these, and I'll teach you the definition too. We're good to go.
I was like, is it awful if I don't stay for the actual competition about eating? Because I need to start.
Oh yeah, I do this.
Oh yeah, I have to look at it. Why are you doing? Because I'm a freaking genius and I did a filing test. So.
Yeah, we should just throw it in the test now. Video on the what's it called?
I don't know what you're talking about. Yes. And it's a 2-day assignment, so we can hit it tomorrow.
Well, then I knew what the heck. Did you guys go over the non-calculated? Do you want to? I need that.
What's your question?